Okay, Mod 5, Lesson 7. Our objective for this lesson is I will be able to solve word problems involving volume of rectangular prisms with whole number edge lengths. So we have been working on with volume, but we haven't applied as much for a word problem yet. So that's what we're going to be focusing on in today's lesson. Essential question, how can I use pictures to help me solve word problems involving the volume of a rectangular prisms? Now, we've used tape diagrams. We're not really going to be using tape diagram. We're just going to be drawing a diagram of a rectangular prism to help us solve this. All right, the standard is MASS 5, MD35A. Now, like I said, you don't have to copy this down, but I would go ahead and paraphrase, which means just shorten it and put it in fifth grade friendly terminology for yourself, okay? Now, the biggest part of this, it says relate volume of the operations of multiplication and addition to solve real-world and mathematical problems in volume. And specifically A, it says they want you to find the volume of a rectangular prism with whole number sides by packing it with unicubes, which we're not going to be doing today, and show the volume is the same as found by multiplying the edge lengths equivalent by multiplying the height by the area of the base. Represent three whole number products as volumes. Represent the social property of multiplication. So we're really going to be using just the numbers and multiplying the lengths times width times height. But if we can, we'll use the area of the base in order to solve it too. Okay. So Godfrey's first planter is 8 feet long, 2 feet wide. The container is filled with soil to the height of 3 feet. What is the volume of the planter? Okay. So first thing I'm going to do is I'm going to draw a planter. Nothing more than a rectangle. And then I'm going to go out here, come up. Now there's my planter. Now, he says it's 8 feet long, so I'm going to put 8 feet right here. It's 2 feet wide, and then it says 3 feet high. And it wants to know what the volume is. And I know volume equals length times width times height. So my length is 8 feet, my width is 2 feet, and my height is 3 feet. So I've got 8 times 2 would be 16 feet squared times 3 feet. And I know 3 times 10 is 30, 3 times 6 is 18, so it's going to be 48 feet cubed. So I know the volume equals 48 feet cubed. Okay, in this problem, it said Godfrey wants to grow some tomatoes in 4 large planters. He wants the planter to have a volume of 32 cubic feet. He wants to put them all in show 4 different ways Godfrey can make planters and draw diagrams with the planter's measurements on them. Okay, now when you're trying to do this, easiest thing is to start with the volume. So we know we have 320. Well, I'm going to decode this, and I know I can go 32 and 10. I've got 2 dimensions. Now I need a third dimension. So I'm going to take this 32 and I'm going to split that up, and I'm going to go, let's see, 8 times 4, because that's 32. So now I have a dimension of 8 times 4 times 10. So that's our first one. Now let's do it again. 320. This time I'm going to split it up, and I've got 32 and 10, same as before, but I also know 32 can be made by making 16 times 2. So now I have 16 times 2 times 10. Let's start with 32 again. 320, I mean. This time I'm staying with a 32 and 10, but now I'm going to come to the 10, and I know I can go 2 and 5. So now I've got 32 times 2 times 5. My last one, I'm going to start with 320, and I'm splitting it up once again, 32 and 10, but I haven't done this one with 10 and 1 yet. So now I've got 32 times 10 times 1. Now they said draw and label the dimensions, so I'm going to do a quick drawing here. There's my drawing. And I'm going to say that this is 8 feet by 4 feet wide by 10 feet tall. Now, I didn't say it had to be realistic, okay? And I'm just coming up with quantities that give me 320 feet cubed, okay? I forgot to put the feet cubed up top, so let me go ahead. Now for my second one, I'm just going to draw another one. And this one, I'm going to go 16 feet by 2 feet by 10 feet. My next one, I'm just labeling the sides. This one's going to be 32 feet by 2 feet by 5. My last one, it's going to be 32 by 10 by 1. Okay, so the key was just decoding 320. All right, next. Godfrey wants to make one planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build a planter so not to be taller than 3 feet. Okay, now the limitation they've put on us here, and let's go back and highlight what they want. He wants to extend just below the back window. The window starts 3 feet off the ground. He wants the planter to hold 36 cubic feet. And it has to be no taller than 3 feet. So 3 feet it can be. Okay. So now let's come back and just remember what we did last time. I'm going to take 36. Oops, not 32. 36. And I'm going to decode this. And I want one of them to be 3. Okay. Well, I know 3 will go into 36 12 times. So now I'm going to split up this 12, and I've got 12, and, well, I can do many of them. Instead of 12 and 1, let's do 4 and 3. So now I've got a 4 by 3 by 3. So let's label our box. And I want it 4 feet long. I want it 3 feet wide and 3 feet tall, because it says it's not taller than 3 feet. Now let's double check ourselves. 4 times 3 times 3. 4 times 3 is 12. Times 3 gives us 36 feet cubed. Okay, so we've met all the requirements. After all the gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide by 8 feet high. So let's go ahead and draw that shed real quick. And we know that it, like he says, it's 6 feet long by 5 feet wide by 8 feet high. Now, it says he realizes he needs a shed with 480 cubic feet of storage. Will he achieve the goal if he doubles each dimension? Well, what that's telling us is that we're going to take this original shed and we're going to double each dimension. So there's 6 feet, and this is going to become 12 feet. This 5 feet has become 10 feet, and 8 feet will become 16 feet. So let's see. We have 12 times 10 times 16. Well, I know 12 times 10 is 120 times 16. So 120 times 16 is going to be 0, 12, 720, and we end up with 1,980 feet cubed. Okay. So did he make that? Yes, he did. Now, let's go back to the original one. Let's see. 6 times 5 would have been 30 times 8. That'd be 240. Notice, if I just double the volume, did I come up with the same answer? And that answer is no. You have to double the dimensions and then work it out, not just double the volume from the original shed. That's the biggest mistake. If he wants to keep the height the same, what other dimensions could he use to reach the target volume? Okay. So he wants to just draw our tape diagram, not tape diagram, but a visual representation of the shed. Now, so he wants to keep the same height. So here's 8 feet. Now he wants to keep the dimensions the same. So he doesn't want to keep them the same. He wants to reach his target. So I know 8 feet times something has to equal 480. So I'm going to come over here and I'm going to start with 480. The first thing I'm going to do is I'm going to start with 8 because I know that's the given. Well, I know 8 will go into 48 6 times, so it's going to go 60. Now I got various ones. I could go 6 and 10. So here is one he could do. He could go 6 by 10 by 8, and he would be able to meet his volume requirement. Okay, so you notice we used a new skill in this one, and this was decoding. You got a pen. Decoding volume. Now, it's the same as decoding a number, but I can take any number. Let's say I have 210, okay? And if I want to come up with 3 dimensions or 3 numbers that I can multiply together to get that number, I'm going to start by just finding 2 factors that give me that number. And in this case, it's easy because I had some power of 10. I'm going to go 21 and 10. Now I have various choices, okay? I know 7 times 3 is 21 to give me 7 times 3 times 10 to give me 21. Now, I could also go the other way. I could have 21 and I have 10. I could go 2 and 5. So now I got 21 times 2 times 5. How about, can you think of another one? Well, I haven't used all of them yet. So if I have 21 and 10, how about 1 and 10? Now I've got 21 times 1 times 10. And you see, this is just a real quick way in order to find 3 dimensions that equal a number. Okay? All right, use this when you're working with volume and it will help you a lot. I'll see you later.